Chapter 1, Circuit Variables. In this lecture, we will review the mathematical expressions for current and voltage, and will determine how to establish current direction and voltage polarity. We will then perform examples using the passive sign convention. We are looking at the following learning objective: to be able to use the passive sign convention to calculate the power for an ideal basic circuit element. We defined electric current as the rate of charge flow expressed as dq over dt, where I is the current in amperes, Q is the charge in coulombs, and T is the time in seconds. Let's look at how to determine the direction of current. We use an arrow to indicate the reference direction of current flow. Assigning the reference direction for current is entirely arbitrary. For instance, current can flow from left to right or right to left. However, once you have assigned the references, you must write all subsequent equations to agree with the chosen references. For example, let's say the current I and I sub B is equal to 3 amps. So we'll assign this a value of 3 amps. The direction of flow is given as from left to right. If I were to change the direction of flow from left to right to left, now what value would we give to the current? We would give the value of minus 3 amps. So when we change direction, we change the sign of the current value. Likewise, if our starting value is, let's see, if our starting value is minus 3 amps, and we change the direction of the current flow from left to right to left, the value for the current would be plus 3 amps. So again, we change the sign. When we change the direction of our current flow, we change the sign of the given value. Note that there is no net positive or net negative charge accumulating in the circuit element. What does this mean? It means that a positive charge entering the circuit element must be accompanied by an equally positive charge leaving the element. Thus, the same quantity of current entering the left terminal must leave the right terminal. So if we have 3 amps entering the left terminal, we must have 3 amps exiting the right terminal. We defined voltage as the energy per unit charge expressed as dW over dQ, where V is the voltage in volts, W is the energy in joules, and Q is the charge in coulombs. For voltage, we use the plus-minus polarity convention, shown in the figure of the circuit element. Voltage can be described in a variety of ways. Let's use our basic circuit element, which could be a battery, a resistor, an inductor, a capacitor, or something else to help describe voltage. We could say terminal 1 is V volts positive with respect to terminal 2. Putting it another way, in terms of potential difference, terminal 1 is V volts higher than terminal 2. In terms of work, it is clear that moving a unit charge from terminal 2 to terminal 1 requires V joules of work. We may also use a double subscript notation, V12, to denote the potential of point 1 with respect to point 2. In this case, we have, in general, V12 is equal to minus V21. So if V12 is 5 volts, then V21 would be minus 5 volts. Some prefer to describe the voltage across an element in terms of voltage drops and rises. A voltage drop of V volts occurs in moving from terminal 1 to terminal 2. In contrast, a voltage rise of V volts occurs in moving from terminal 2 to terminal 1. As an example, if we have a voltage of 10 volts on the terminal 1 side, actually I'm going to move that up. So if we have 10 volts on the terminal 1 side, and we are going through a voltage drop of V volts, then on the terminal 2 side, we would have 10 minus V volts. If we're starting with 10 volts on the terminal 2 side, we're going through a voltage rise from terminal 2 to terminal 1. So on the terminal 1 side, we would have 10 plus V. Can you see that? Plus V volts. You will see these descriptions of voltage in problem statements. However, this one is what we will most commonly use throughout the class. Now let's take a look at the passive sign convention. In circuit analysis, the convention is to draw the direction of the current entering into the positive terminal of an element. Therefore, the reference direction for the current in an element is in the direction of the reference voltage drop. We call this convention the passive sign convention. Specifically stated, the passive sign convention is whenever the reference direction for the current in an element is in the direction of the reference voltage drop across the element, as in figure 1.5, use a positive sign in any expression that relates the voltage to the current. Otherwise, use a negative sign. Again, I would like to state that assigning the reference polarity for voltage and the reference direction for current is entirely arbitrary. However, we follow the passive sign convention, and once you have assigned the references, you must write all subsequent equations to agree with the chosen references. This becomes especially important when determining if energy is being delivered to or absorbed by an element. Okay, as I stated, our convention is to set our reference direction for current such that the positive charge is moving across a voltage drop. We will be talking about power and the power equations a little bit later. But let's take a look at some examples. If our voltage is assigned a value of 10 and our current is assigned a value of 4 amps, then in each of these pictures, our current is positive 4 amps and our voltage is positive 10 volts. So let's write that for each one. So positive 10 volts, positive 4 amps. Positive 10 volts, positive 4 amps. And last one, positive 10 volts and positive 4 amps. Now, I want to change these such that they reflect the passive sign convention, where the direction of the current flow is entering into the positive terminal. So let's do that for each example here and see how that changes our value of current. So in our first example, the current is entering into the positive terminal and it satisfies our passive sign convention. For the second one, the current is entering into the negative terminal. So let's change the value of current, and now it becomes minus 4 amps. Okay, so we would use those values in future calculations. In the third example, again, the current is entering into the negative terminal. So I can change the direction of the current so that it's on this side, entering the positive terminal, or I can change the direction of the voltage polarity. So let's change the direction of the voltage polarity. And when I do that, it changes my value for voltage to minus 10 volts. In the bottom here, we have our current is entering into the positive terminal, so it is following our passive sign convention. Now we'll be talking about power and energy in the next lecture, but if you use the passive sign convention and change the directions of your current and voltage polarity to satisfy the passive sign convention, then you only have to remember one equation, P is equal to VI. And again, we'll talk about that in the next lecture. Okay, so again, this is a problem we can do in the next lecture, but we have an assigned polarity here, which is a value of 4 amps, and the voltage is minus 10 volts. And a classmate assigned polarity a little bit differently and came up with minus 4 amps and positive 10 volts. So let's take a look at the differences here. The polarity of the voltage is opposite, and the signs of the voltage is opposite. The direction of the current is opposite, and the signs of the current are opposite. So in review, we introduced the concepts of current direction voltage polarity, and the passive sign convention. And we did a couple examples, which we will revisit once power and energy have been defined. And that concludes this lecture.